This isn't your typical clone. This is Randy Rhoads' Tone reborn. I'll be building it by hand, just like they did in the 70s, only I'll be sharing my knowledge gained as a Royal Navy Chief Engineer over the last 23 years. I've been building pedals at sea, in the Royal Navy's engineering school. I've been building them all over the world. Just wait until you see what I've got in store for the diodes. I've got something incredible, and I'd love to know what you think of the sound. Well, this is one I've been waiting to do for the longest time. It is the Randy Rhoads Distortion Plus. Loads of people have asked me to do it. I've finally got round to it. We're going to be using this. This is my enclosure. It is massive, ridiculous. We're going to be building it on tagboard, and also it's got an IC, so we're going to an op amp, so we're going to have it also wires going out to an op amp. It's going to be mental. So what's going on with this? I didn't want to do polka dots as much as I really did want to do polka dots. I didn't want to do it because it's kind of copying what MXR is doing. I don't want to steal their thunder. You know, it's their design. It's probably copyrighted, and I'm pretty sure that you have all told me in the comments how unoriginal I was. So, how's this for being original? We've got a brass panther. I think it's a jaguar. Brass jaguar on the front. His mouth is the stomp switch. His eyes are red LEDs. So to save time, I've already drilled it and fit the hardware inside. We've got a 1 meg gain pot and a 100k volume pot. We've got 2 red LEDs that have been epoxied in place because they are now the eyes. Input and output jacks as normal. And we're going to sit our circuit probably over the top of where the eyes are. Fun stuff. So what do we think about this? While I'm talking about this, I'd love to just say thank you to everyone who's bought stuff from the affiliates links in the description, because I've managed to buy myself a set of these with it, another set of Nipex snips, but they do match my flat nose pliers, and something about me just feels whole having a matching set. So thank you to everyone who buys stuff from the affiliates links. I do get a kickback from Amazon, no extra charge to yourself, but it does help me buy stuff to film with and build pedals with, so thank you very much. Now let's get on to the circuit. For the circuit, we're going to be using this drawing. It is the drawing by Audio Dome of the DOD 250, which everyone who's watched my channel for some time will know because I've built this before. However, the differences between the DOD 250 and the MXR Distortion Plus are rather small. It is the gain pot value, it is the type of diodes used in the clipping section, and that's pretty much it. In fact, I think there was a 10k sometimes added in extra to the to the Distortion Plus, which we're not going to be fitting because it's going to reduce the gain, and we want to get as much gain out of this thing as we can. So now onto the circuit. Okay, before we get into the circuit, I'd like to just talk about the differences between the DOD 250, which is the layout we're going to be using, and the MXR Distortion Plus Randy Rhoads. So first up is the op amp. In the DOD 250, the grey edition, there is an LM741, or in later reissues, LM308 op amp. And of course the Randy Rhoads as an LM741, which we'll be using today. Other differences are 5, which is in series with the clipping diodes. In the DOD 250, it's a 1K. And in the Randy Rhoads, it's a 10K. Now this thing can reduce the gain of the pedal, basically. If we're going to reduce the gain of the pedal, I think it's going to be less effective as a Randy Rhoads pedal. Some of the mods would be to clip out this resistor completely and have no 10K resistor in that position. So we're going to go with that too. The main difference between the two of them is the gain pot. In the DOD 250, it uses a 500k pot, and in the Randy Rhoads, it uses a 1 meg pot. So we're going to go with the 1 meg pot, and we're going to see how it sounds. If it doesn't sound great, we'll go back to the 500k linear. Why not? I have a feeling that linear isn't going to be any good, and what you really want to get is reverse log or something like that, so then you get a smooth sweep. But we'll see all that in the sound sample at the end. Stick around to the end because you're really going to get to see some special diodes in action. It's going to be fantastic. This wasn't just any Distortion Plus. Randy's had bite, it had sag, it could scream. But it wasn't the only thing that made his sound. It was, of course, all in his fingers and in his signal chain, you know, his amp, his cool guitars. We can't recreate that. In fact, I can't recreate that. but what I can do is offer you one of 3 Distortion Plus pedals built to the exact specs that I build today in this video. They'll be available over at hellosailoreffects.com, link in the description or the pinned comment. Thank you for buying pedals from me, it really does help keep the stream alive. So for this you're going to need a tag board with 8 tags, 8 on the top, 8 on the bottom. Full disclosure, I actually started filming this video already. I got all the way along to this point and then realised that I didn't have my microphone plugged in. So back to the beginning we go. Wonderful, what a time to be alive. So first 2 components to go in today are C1 and R2. C1 is a 10 NF, 10 nanofarads for everyone who's about to tell me off for saying NF. I don't care, I'm going to keep saying it. That's going to go between tag 1 on the upper row and tag 1 on the lower row. It's going to just sit in there. Now, R2 is a 10K resistor. And that's going to sit between the first tag on the upper row and the second tag on the lower row. To fit these, I am of course going to clean the legs using my snips. I've had some weird and wonderful suggestions about how to clean legs. Some really good ones like emery cloth and stuff like that. And some good stuff that's available out in America and Canada for cleaning legs. However, I just like doing it this way. Look how easy this is. I've done it for years. I've had lots of people tell me that it's going to blunt my snips. Not with the Nipex ones, it doesn't. They can handle it fine. I've had lots of people tell me I'm going to nick the legs. They're not going to last very long. Well, I've never had that problem. I've never had a complaint of any of my customers saying that a pedal's, you know, had a snap leg on a component. So I'm just going to keep doing it the way that I do it. Now, to fit this first one, I'm just going to use my flat nose pliers, my Nipex matching flat nose pliers. Oh, I'm never going to get over that. To make the legs both the same length. I use it as kind of like a measuring tool. And if we slide that in through the top tag, we can see on the bottom tag exactly where we need to snip that leg off. So then it will fit through. And of course we're going to save our tags because they all come, our legs, sorry, because they all come in handy later on. Now I can't solder the top tag because we've got R2 going in there, but I can solder the bottom tag. So just make sure that that's centered and then wet our tip. Well, hey, I haven't said that for a while. Wet our tip and give that bottom row a solder. And then we can straighten it up, make it look pretty. Or as pretty as old components on a tagboard goes, which I think is pretty. Is that even a thing? Now, R2 goes in the top tag here, which is left unsoldered, and down to tag 2 in the bottom row. Wonderful. I'm having some serious deja vu here because I've literally just done this. Now, we can't solder tag 2 on the bottom row because there is another component going in there, but we can solder the top row. Next on the cards is R3. As ever, I'm sure you've noticed, I'm just going to go through the center line and do all of these components first, then we'll do all the ones on the outside edge, just because I find it easier to do it that way round. And you may want to solder them all in as you go, fair enough. Right, R3 goes from the second tag along on the bottom row to the third tag along on the top row. It's a little bit unusual, skipping a tag on the top row. I don't normally see designs do that, but I do know Mr. Audio Dome, who did this layout, has done that more than a few times in his layouts. And far be it from me to complain about a free layout that someone took the time to make, so I won't. But I do like the look of this circuit anyway, so whatever. Now, the third tag along on the top row is a bit of a difficult one because there's 3 components going into that. So we can't solder it yet, but the next component going in is C7. And C7, according to our drawing, is a 10 microfarad cap. I'm going to be using this Phillips cap. They're all going to be vertical caps today, just because that's what I have in these values. Now, these are polar. If you can get a non-polar cap in there, I always prefer non-polar caps, but if you're going to get a non-polar that isn't an electrolytic, bear in mind that a 10 microfarad, a 10 UF is going to be bloody massive. You might have to mount it off board if you're going to do that. Or you could just get a non-polar electrolytic, yeah, absolutely. But if you do have a polar one, you need to make sure that the negative leg is pointing down. So it's going to the bottom row. So our positive leg, which is the side without the band on. So the band denotes the negative leg. And it's also the one with the longer leg is the positive. That goes up to the top. And then the bottom row is the negative. Now, as it stands, we can solder the bottom row, but we can't solder the top row because there's going to be one more component going in there. And the component going in the top row is R8, which is a 22K resistor. I've got this carbon comp resistor. It's a real old one. It's got quite a wide tolerance range. I think it's like 10%. So this is actually a 20K resistor, but it's within tolerance, being within 10% difference, but it is 22K measuring with my Fluke 101. Now, this is going to go in to the top row, third tag along with our other two components, and it's going to go to the bottom row, fourth tag along. And it's going to complete our triad of components in this tag. What we can't do is we cannot solder the bottom tag because we're going to have another tag with 3 components going in, which is a bit of a pain. But there you go. But we can solder, however, the top tag. So give me solder tip a bit of a clean and then wet the tip. And we can solder them 3 in there now. There we are. Now we're on to this bottom row. Here we've got C6 and R7 going into this tag. So it's another 3 component lineup. Now C6 is a 100 microfarad cap. So 100 UF. 100 UF for you mechanical engineers out like me out there who are too stupid to be electrical engineers. Believe it or not, that's how the Navy seen it when I joined up. Yeah, so 100 microfarad. We're just going to fit in exactly the same way, only this time, as we can see on our drawing, the negative side is going to go to the top and the positive side is going to go to the bottom. Also going in here is R7. We'll worry about that in a sec because I don't actually have that value, but I'm going to go ahead and fit that now. That's C6 now in place and lined up in the center. I've soldered the top tag, but I've left the bottom tag unsoldered because we do have R7 going in there. Now R7 is a 100 ohm resistor. I don't have that. I have these two 47 ohm resistors. Now I know 47 add 47 is not 100. I completely get that. So I'm sure I'll get it in the comments of people telling me to get the right resistor. Fantastic, well done. Not going to happen. The way this works is we're going to wire these in series. So for example, if these were 50 ohms, just to make the maths easy for my simple mind, if I was to wire them, one resistor going into the other in series, we add the 2 values together. So 50 add 50 is 100. However, if we were to wire them in parallel, and I mean, I'm sure you all know this, but I'll just go through it anyway. If I was to wire them in parallel, 50 ohms and 50 ohms now becomes 25 ohms. So we half the amount of resistance. The best way to think about this is if it was a pipe work. If this was a pipe with water going through it and we had this little restriction that reduces the water flow, for example, if we had 2 of them together, that's 2 restrictions slowing down the water flow, or electrons, if you want to think electricity. Now, if we put them together next to each other, yes, we have 2 restrictions, but we have twice as much flow going through them because we have flow going through each one, so the resistance goes down. Perfect. Now, if we're talking capacitors, if we have 2 capacitors and we add them together like this in series, it actually halves the value. It's the opposite way round to resistors. So if we add, this is 6.8 and 6.8 NF, if we add them together, we actually get 3.4 NF. Now, if we add them side by side in parallel, we get double that. So we get what, 12, 13 point something NF. There's my maths not working properly. Dyslexia, what can I say? Yeah, so if we put them side by side, it actually doubles the value. And if you think about these as sort of pushing outwards, like I like to think of them like a fluid accumulator because I'm a mechanical engineer. But if you think about that, there's two of them working together, so you get more out. I don't know why I felt the need to tell you that, but I did. Now, to add these two together, I am going to do my usual method, which is, of course, the helicopter method. And regular viewers of the channel will know that I absolutely despise them death traps. You would never catch me up in a helicopter. I pull more of them bloody things out the water than you. Oh, ridiculous. I think the pilots in them things are insane. No way. Now, so I twist them together like a helicopter rotor and then give that a solder. Apologies to people who have seen this like 7 billion times, but you never know. There might always be someone new to the channel who's watching. So now we have our two resistors in series. So this is going to be as close to 100 ohms as I can get. What I can do is I can either bend the legs out like that, or I can bend the caps out and have them in a straight line. I'm actually going to bend the legs out so then they sit upright, like so. Now this is going to go through the fourth tag along on the bottom row with our other components going into it. And then the fifth tag along in the top row, where I'm not going to be able to, oh yeah, I will be able to solder, sorry, I'll be able to solder both ends of this because there's nothing else going into these tags. And I kind of like that because it means that it's all secured in place and not going anywhere. Perfect. There. And if we tidy up them tags. Good. Now, next along, which is going to be the fifth tag on the bottom row, we're going to have R4 going in. R4 is a 4.7K resistor, like so. And that's going to sit in the fourth tag along on the bottom row and the fifth tag along on the top row. Now, if we look at our drawing, we can see that C2 also goes into this top row. So C2 goes from the fifth tag, is it fifth? No, sixth tag along on the top row, straight down to the sixth tag along on the bottom row. C2 is on our drawing, just double check, is a 47 NF, so 47 nanofarad or 0.4047 microfarad if you want to go that way, but 47 NF. And for that, I'll be using yet another ITT cap. This one's labelled up TCC, but same brand, same manufacturer. And that's going to be going in there. There's R4 and C2 in place, all soldered in because there's nothing else going into them components. Perfect. Next in line is C4. Now C4 is a 4.7 microfarad cap, and I've got this. It's a Dubelier cap, again going with the stand-up theme, the vertical theme of my other electrolytics. I used to go through and pull all these off and scrape the legs when taking them off these strips. And for some reason, if you're pulling up against these legs, for some reason it's going to pull the leg out or whatever, and you could do some damage to it. I just never considered just simply snipping them off. It's so simple, but it eluded me for the longest time. So if we snip them off, our legs may be a bit shorter, but we can straighten them out with our flat nose pliers. And you know what? They fit between the tags, so it doesn't really matter. And then, of course, we're just going to bend our legs out. If we look at our drawing, we can see that C4 has the negative at the top end and the positive pointing towards the bottom end. So that means that the longer leg goes to the bottom, shorter leg to the top. Then we can just solder the bottom leg, so the positive side in place, but we leave the top side free, if you like. And that's because there's more components going into the top side. So our next component going into the top side is R6. Now R6 is a 10K resistor. Loads of 10K resistors going on with this one, but there you go. Right, now R6 is going from the top of C4 down to our 8th tag on the bottom row, which is going to attach to C5. Now, the astute among you will have noticed that I've run out of tags here, but our drawing is showing that we have an extra tag on the end. The reason being is this drawing is set up for asymmetric clipping, because we have, you can see there, D1, D2 and D3 are all set up for asymmetric clipping. But our circuit doesn't have asymmetric clipping as such. It has symmetrical clipping with germanium diodes, which gives a completely different sound, really, different response. And I actually prefer the germanium diode set up symmetrically in this circuit. So next up, we've got C5, which is going to go from the 8th tag along on the bottom row to the 8th tag along on the top row. C5 is a 0.001 UF or a 1 nanofarad, so 1 NF, and I've got this, or 1000 picofarad if you want to be a smart ass, but so I've got this one here anyway. Now to fit this in, it's going to get in the way of my diodes, of course it is, because our diodes are going to go into the same tags here. So if you imagine where D1 is fitting in our drawing, we're going to put D1 opposing D2 into the same tags there. But what I'm going to do is I'm going to fit our capacitor in the center tags, and then I'll use the outside tags to fit our diodes in symmetrical clipping. I mean, you could mount the diodes off board or under the board or something like that if you really wanted to. But I think the way that I do it in this one is going to be just fine. We could get something a bit more out of our diodes. I've got something really special in stock. So stay tuned and you'll get to hear and see the amazing idea that I've got for these diodes. It's going to be a bit out of left field, so let's get on to that. So why is it that I always like to use tagboard? I think it just makes the pedal look better inside. It gives a bit more space in between the components, and I really do think that parasitic inductance is a thing. If you don't think that, that's fantastic too. If you think that the expensive components that I use are ridiculous, that's also fantastic. It's a valid point. However, I think you're watching the wrong channel if that's the case. You're welcome to build this pedal with cheap components and then let me know in the comments. Let me know how you get on. It would be fantastic if I inspired just one of you guys to build this with cheap components, and let me know what you think. Thank you for watching the video, and I really do hope you pick up a soldering iron. Right, before we get on to the diodes and the amazing idea that I've got, I am actually going to go ahead and just fit all of the outside edge components. So first up, on the bottom row, we've got R1. Now R1 is a 2.2 meg resistor. That is a pull down resistor from the input. I normally use 1 meg on my pedals. 2.2 meg is fine too. I have these carbon comp resistors that are 2 meg. So I'm going to compromise and go with a 2 meg. You could use 1 meg, you can use 2.2. You can go higher if you want, but there's really no need. All this is going to do is any voltage from the circuit that bleeds through our input cap, because as we all know, capacitors don't pass DC, but they do pass AC. But no cap is perfect, so they all do pass a little bit of DC. All this resistor is going to do is just bleed that little bit of DC that they do pass down to ground. Now ground is the 3rd tag along, so it's going to go from the 1st tag to the 3rd tag. And all I like to do is just line it up and bend the legs down, so then it's going to slot in these center holes. And then all I have to do is snip the legs at the height that I want it to sit, which is reasonably high. Oh, look at that. How far off of it? How far off of it missed them holes by? Jesus. What are you doing, Joe? It's been a long week. I've had one of my guys kicked out the Navy for failing a drugs test, so I've been busy doing that and a few other disciplinary things, which has been a bit of a time suck, really. Not too happy with that, with having to do my job, really, I suppose. Right, so we can just, because the legs are snipped to the right height, well, they would have been if I hadn't got the distance wrong, snipped to the right height. All we can do is we can slot that in there, and the components will sit sort of square and flush exactly where we need it to go. and then we can just solder the legs into them centre holes. If you're going to use the centre holes and you're going to solder into them, just be aware that you're going to need a bit more heat in there and be a bit more competent. You're going to have to be more confident and competent, really, with the soldering iron, because otherwise you can overheat your components. It really does help if you've got something like the Hakko that is like super hot. I have a lot of people ask me what temperature I like my soldering iron. I like it as hot as it'll go. So the Hakko goes to 477, whatever that is. I'm assuming that's degrees Fahrenheit. I don't know. It's definitely not centigrade, is it? 500 degrees centigrade. Maybe. Anyway, I like it as high as it'll go. There's R1 in place. Now next on the bottom row, we've got C3 and R5 going into the same legs. So C3 is a 25 picofarad cap, which I've got this. It's a Silver Mika 22 picofarad cap. I'll just destroy that bag there. Go on, Joe, why not? This is a reasonably nice cap. It's way nicer than what needs to go into this position. But, you know, I have a lot of people saying, why use anything expensive in these pedals? And, you know, you can make the same thing with SMD and all this jazz. It just wouldn't be a Hello Sailor if it did that, would it? So this is going to go between C4 and C2, which is here. And also, we're going to have a resistor in there, which is R5. And R5 is a 1 meg resistor. So we're going to have this 1 meg going in there. Now, the choices are, I can lie them next to each other and just, you know, solder both legs into the same thing. Or I can kind of solder them in across like this and then just solder them in. I'm actually going to lie them next to each other for this one, just because both components are small, so there's place for them to sit side by side. It's not like congested and anything. If they were larger, I'd probably put the resistor across the cap legs and just solder it in that way. I mean, there's loads of room in our enclosure because it's bloody massive. Unnecessarily massive, I would say. But it's a good job we went with a big enclosure, because our diodes are really going to need it, I think. They're going to have to sit high off the board. Especially with the special idea that I've got. You're going to love it. So do stay tuned. Right, if I cut both of them legs the same length, they're just going to slot in and sit at the right height, as so. Now I can solder both of these in place now, because there's nothing else going in these legs, and because I've cut the legs at the right height, they're kind of just resting exactly where they need to be. Yeah, one hell of a week for like admin and stuff. Discharging someone from the Navy for a drug offence is like so long-winded. Like, there's so much faffing about. It's a shame, because the guy's actually pretty good. I would have preferred to have kept him in and just reprimanded him, but the Navy has zero tolerance towards drugs, so you just straight out. Right, that's them two in, as we can see there, and that is our bottom row all sorted out. Now the top row, we have D4 and R9 next to each other. So D4 is a diode. Basically, this is just a power diode to stop the reverse polarity. You know, if someone plugs the wrong power supply into the pedal or whatever, that's what this is for. On our drawing, it's telling us that D4 is a 1N4002, fine. But you could use any of the 1M variants. So 1M4001, 00, whatever. I've got a 1M4007. They're my preferred ones, and mainly because they're rated to the right voltage to use in amplifiers as rectifier diodes, which I have done in the past. So I just bought a load of them. That's going to do that job, no problem. And we can see that that goes between the second tag along, and it has 2 tags underneath it, and then it drops in right by R7, which is the 1, 2, 3, 4, the 5th tag along. Now, these diodes do need to go in the right way round. This one particularly, because if you put it in the wrong way round, it'll just short your voltage straight to earth, and you won't have any voltage get into your pedal, which is, you know, clearly not good. So it goes in there, misses 2, and then goes into the bottom or to the top even of our 100 ohm resistor, which is R7. So all I do is measure the legs out as before and then cut them to the height that I want them to go and slot it in there. Again, before I solder anything, I'm just going to have a double check and make sure that I've got the line on my diode pointing in the right direction, which is the right hand side. That is correct. And then I can solder that in place. Again, with diodes, as I've said in the past, these are one of the components that really don't like too much heat, especially when we get to the germanium ones. The 2 tags in between this, so the 3rd tag along and the 4th tag along, are going to have R9 in them, and R9 is another 22k resistor. So I'm going to go and get one of them carbon comps that is over spec, the 20k over spec. I'm going to go and dig one of them out now. There's our 22k resistor fitted on the outside edge here, R9. That is it for the components. All that's left is, of course, the diodes. Now, the Randy Rhoads Distortion used germanium diodes, and the forward voltage of the germanium diodes used was 0.25 volts or 0.35 volts, or somewhere in between. So to get this, I'm going to be using these Soviet era germanium diodes. They even come with the little data sheet and what have you, or for my American friends, data sheet, which is fantastic. It's kind of like Josh with he has the box flex, get in. But just to add in a little bit of a twist, because I want this to be really special and justify having this massive, you know, this massive enclosure, I need to add in something a little bit more. And so I'm going to use this. Now this is a circuit board from NKT, Newmarket. I got a batch of these boards. They normally have a little sticker on there that says Newmarket. And so all of these diodes, all of these transistors on here are actually NKT transistors. They're just not labelled up. I think they have like C5 or C4 wrote on them. But some of these could actually be NKT 275s, just not badged up, because, you know, why would they badge something up that's just going straight onto a board that they're making themselves? Interesting stuff. These are two power transistors. But these 2 transistors here, this is where it really gets interesting. So as you can see, these have only got 2 legs on them. That's a bit weird for a transistor, no? But if we look a bit closer, we can see that one of the legs is thicker than the others. So that got me thinking, why would you have a transistor-shaped object with 2 legs and 1 leg thicker than the others? And that would suggest to me that it is in fact a transistor wired as a diode. So if we open up the heat sink on there and pull it out, we can see that they are indeed, well, this one's not labelled up, brilliant. Let's see if it's labelled up on this one. Would you believe I've pulled the one bloody board out that hasn't got them labelled up? Hang fire, I'm going to go and get another board. I want them to be labelled. Right, take 2 on this one. This is in another board, exactly the same, from the same batch. Only this time we've got our little sticker still on there, on Newmarket, transistors limited, PC5 Plus, which is the type of board it is. We can see these ones are actually labelled up. And here's our 2 suspect transistors that I think are just wired up as diodes. So let's open them up and see what we got. So these are NKT badged because, well, they are 279As. Now, they're actually transistors, but they're wired up as diodes. So if I give that a snip out, we can see, what I don't want to do is take away all of this sheathing, but we can see on there that there's 2 legs in this one leg, if you like. So it's just a transistor, an NKT transistor, germanium, wired up as a diode. So I thought, I wonder what the forward voltage on these are, and can we use these in our MXR Distortion Plus? MXR Distortion Plus, it's going to be a Hello Sailor Distortion Plus Randy Rhoads pedal. Because, you know, these are pretty vintage, the NKT germanium transistors. like the thing that everyone searches out, if you like. Now, the good thing about this 101 is you can flick it round to ohms and press this yellow button twice, and it takes you to diodes. Now, if you add these the wrong way round, i.e. you get them on the wrong legs, you won't get a forward voltage. Just now we have, let's see if I can get that out of the light of the old video light. It's reading 0 voltage, and that's because I've got them the wrong way round. So if I switch them round, we can see that this diode is putting out 0.1 volts. So that is 100, and we want 250 to 350, remember, and this is only 100. So there's that one, and then the other one is kicking out. I just think this is going to be so cool, having NKT labeled transistors. This one is kicking out 96. So basically we need to find another 150 to 250 to make up the difference on these, to be able to give us the forward voltage that we want for our Randy Rhoads pedal. And that's where these bad boys come in. Now, let's see, which way round do these go? So there's, straight away, look at that, 147. If we were to add 100 to that, that's 250. That'll give us our forward voltage that we want. And the next one along. So I'm going to use these first two. They're never going to be exactly right. But what we've got to make sure that we do is get them so then they're pointing in the same direction. Now, how do we figure that out? If we have it so that then our black lead is on the right hand side, i.e. with the NKT, black lead on the right hand side, red lead on the left hand side, we get a voltage. That's good. If we do the same to this one, we don't get a voltage. Spin it round. Now these are pointing in the same direction. Okay? So black lead, red lead, black lead, red lead. Now what we're going to need to do is have it so then one diode feeds into the other. So if you imagine this is our half with our band around it, the black side, and the red side doesn't have a band. This is our half of our band around it, and this side doesn't have a band. So the band on this one needs to feed into the side that doesn't have a band on this one, like that. And then that way we will get our voltage, you know what I mean? So we have a unbanded side, banded side. I hope that's making sense. If it doesn't, please let me know and I'll go into further detail in another video. In fact, I think I pretty much have gone into further detail in other videos. So what I'm going to do is I'm going to solder these two together in series, and that's going to give us one diode with about 250 forward voltage. And same again for these ones. Two diodes wired in series to double their voltage. If I put my flute back round into diode mode, our black lead's going to go on the left hand side, red lead on the right hand side, and we get 250 just about on this one. I think this one's a little bit less, 233. Close enough for government work. There's our two diodes. How cool is that? NKT transistor as a diode. Now to fit them, they're going to go into this end tag here, which is over the top of C5. And all I've done is I've spaced the legs so then they can just simply slot into the center holes. And don't forget, it's going to be symmetrical clipping, so they've got to go the opposite way round, because this will clip one half of the sine wave, this will clip the other half. So all we have to do is fit them in, he says. There. And now if I solder them legs in, we should have our diodes in place. And again, these are really what you want to pay attention to. Germanium diodes do not like, much like germanium transistors, do not like a whole ton of heat in there. So you do want to have a hot iron, and you want to get in, get it done and get out, because, you know, not having a good solder joint and going too flimsy on the old holding it on for too long is bad, but also burning out your diode slash transistor is also bad. So if I just straighten them up now and keep them away from each other, I mean, I just think this adds a whole cool dimension to this pedal, having the vintage NKT germanium transistor wired up as a diode with a vintage Soviet diode. I mean, we have the board that the transistor come from. It's just interesting, isn't it? Now it does sit quite high off the tag board, but of course, look how deep this enclosure is. It's not really going to matter. Each of these tiny little germanium transistors are what are going to make this pedal special. It's going to make this like no other pedal you've ever seen. And if you want to own one of these, remember, they're going to be available at hellosailoreffects.com. These are going to give us that soft but also crushing clipping that Randy was known for. It's going to be full-on distortion, but it's also going to have a rounded edge to it. And these diodes are just something a little bit special. It's going to make your pedal unique. Before we get stuck in, I'm going to sort out the LEDs, the eyes. So we're going to have to wire up our positive side of each LED going to the positive on our 9-volt supply. And then we'll use the negative sides, we'll just connect them together and run them round, and that can be switched on this switch here. Real simple. Real simple, he says. I'm probably going to mess it up. So to do this, I'm going to bend over both halves of the LED, the positive and the negative, just so that then I create like a flat edge that our tag board can now sit on the top of. I mean, there's plenty of room in here, so we can get it on top of there like this. And the longer leg is the leg that is the live. So I'm just going to run a 2.2k resistor from the positive of our 9-volt jack down to the longer leg and just solder them straight in there. And that'll mean that we have the same power supply going to each. Now normally I go for the 10k resistor, as people will probably no doubt know, just so then the LEDs aren't as bright, but I really do want the eyes to be a bit brighter. So I'm going to go with 2.2k. Both of the resistors are now fitted. I've also joined together the two negatives because I'm going to run a wire straight down, probably come around this outside edge here, and up to our 3-pole double throw switch. Now we've got our two earths tied together. The next step is, of course, running that wire around the outside edge and to the centre pin of our 3-pole double throw switch. Now to do that, I'm just going to strip the end of my wire, twist it together, and then tin it. Once it's tinned, it's easy to make a hook out of it. And I know some people dislike my hook and loop method, or so I like to call it. But it's easy to make a hook out of it. And I can now just hook that round the bare metal of one of the earths or the negative side of our LEDs. Now when I solder that in place, that's going to put both LEDs, giving them a route to ground, which is what we want. That way, when the switch goes on, when the switch activates, it's gonna basically activate both at the same time. And I said the center pin before. That's absolutely wrong. That's where the earth goes. It is, of course, the front center pin, because our earth will be in the center. When it's in a disengaged position, it'll earth out our input. When it's in the engaged position, it will send an earth for our LEDs. Right. Nice and easy. The reason why I'm doing this before fitting the circuit is because I'm going to fit the circuit above this, so it kind of makes it a bit difficult to fit once the circuit's in place, because obviously I'll be soldering like kind of under the board, which makes no sense whatsoever. Might as well get it done beforehand. There. Now I'm going to go ahead and fit the circuit so it's sitting right above here. And we're going to use the methods used in other videos, which is, of course, steel reinforced epoxy and double-sided sticky foam. Okay, so we can see we've got the two boards fitted now. We've got our tag board that we've just built, and we've also got this power filter board. Now, if you want to see how this power filter board works and how it's built, then please check out any of my other videos. It's pretty much in most of them. For this purpose, I'll just put on the screen now, you'll be able to see a layout done by my good friend Jimmy, who sorted me out with, well, he does loads of layouts for me because he's a legend. But it's basically just two caps, one filtering big frequencies, one filtering small frequencies, and then two resistors, one on the input and one on the output. Done. So, how are we going to wire this up? First of all, I'm going to tackle the ground wiring, just because I've got this wire swinging in the wind. And we all know that it annoys me, so I'm going to sort it out. And what I'm going to do is I'm going to run that round to the center pin of our 3-pole double throw switch. It's then going to come out and go around our wiring loom and up to the 3rd tag along on the bottom row, which is our earth for our circuit. Then it's going to come out of there and go round the top here and up to this upper row where there is 2 earths. We can see on our drawing now that the 4th pin along, the 4th tag along, sorry, and the 2nd tag from the end are all, well, it's not the 2nd tag from the end, that was almost caught out there, weren't I? Because our drawing is a 9 tag board, but we've done ours on an 8 tag board. It's actually the end tag. So it's the 4th tag in and the end tag. And what that last earth is for is obviously the diodes clipping to earth because they're hard clipping. So we're going to go to that and then we'll come back out and we'll go through our, both of our pots are going to have an earth on them, and also our 9-volt barrel jack and our 2 input and output jacks. Our earths are now in place. We've got this bar going across the top. I need to solder these 2 bits in, but this bar going across the top. We've got our jack going into it. We've got 1 line coming out of solid core transformer wire going to each pot. So our gain pot, which remember on our drawing, as we can see, is a 500k pot, but in reality the Distortion Plus, as previously discussed, has a 1 meg pot, so it's much more gain involved there anyway. So that's going to go to earth, and then also our 100k volume pot, the pin 1 of our pot is going to ground 2. We've got a wire coming out and it goes to the 2 earth slots on our top row of our tag board. Then it comes round and goes into our 3-pole double throw switch, and it comes out and goes round to our power supply board or our power filter board. Now, can anyone spot what I've done wrong here? And this is why you should always run over all of your connections. I have in fact missed going into here, pin 3 or tag 3 on the bottom row of here. So what I'm going to do is I'm going to run a wire from one of these top jacks, which I still need to solder in, round our wiring loom and then up into the board at tag 3 here. It's a good job we checked these things over, otherwise the pedal wouldn't have worked and I'd have been scratching my head later on trying to figure out what went wrong. Now it's time to tackle what I would like to call the prime mover. It is, of course, the op amp. And we're going to use a tiny little board like this. We can see on this drawing here that we have just enough holes on our veroboard to fit in the op amp itself and have a row of holes either side to attach connections to. So our op amp is going to slide, this is an op amp socket, I do highly recommend using the sockets, but our op amp is going to slide in there. What we need to do is have a row of holes going through the centre here, and that's just going to separate each side of the op amps. So this row here is going to be our holes. You could hacksaw this row, you could use the correct tool for the job, there's a little drill piece that you can use, pillar drill, all that sort of stuff. I'm going to go ahead and just use my Stanley blade in a circular motion in each hole and just take out the copper trace. Why? Well, because I've always done it that way, and I hate that answer on board Watership. When I ask why we're doing something stupid, I'll get, "Chief, it's because we've always done it that way." And I hate that, but the reason why I'm going to do it this way is because it's the way that I feel comfortable. It's got nothing to do with better or worse. It's just what I'm used to and what I like doing. I actually enjoy building these pedals, and part of it is doing this sort of thing. So I know I'm going to get slain in the comments for this, no doubt. That's what usually happens. So like I said in the beginning, this pedal isn't built like it's built by a pedal builder. It's built like it's been built on a warship, because we just adapt and overcome and use what you've got. Now we've got our row of holes. We can situate our socket, and I do recommend using sockets mainly because if you solder your IC in there and it doesn't work, you can't easily change it out. So we're going to put our socket in there, making sure that our little notch on the socket is pointing upwards, because that's the way that it's facing on our on our layout. If we get that the wrong way round, we may fit our op amp in upside down and then the whole thing won't work. Because it's just the op amp in there, no other components, it's easy just to turn it round, lie it on its side, and then lie it on its back, and then you can wet the tip and just go ahead and solder each each leg in place. Remembering that we're also going to need to solder in wires coming from the outside edge of all of these, so don't blob the solder on too much so then you can't get into the holes next to it. That would be a mistake. Right, now that that's in, we can just cut the excess off the ends of them IC legs, or the socket legs. There. Now, back to our drawing, we can see that on the left-hand side of our IC, we have 3 wires. One's an earth, and then coming from pins 2 and 3. And on the right-hand side, we have 2 wires coming from pins 7 and 6. So that's 5 in total. What I like to do is just take a long strip of wire. I mean, I have my wire on this bad boy. It's a Hakko like solder and wire dispenser. Godsend. Just means that they're both together, not in the way type thing. But I like to just take a healthy length of wire, way more than I'm going to need. And then I'll just take 5 of them. And what we can do is then we can strip and tin and then place in the circuit each wire. So then when we stick this board inside our pedal, it's already wired sort of to the board, because we can't get under the board to solder once we fit it in our pedal. Another great thing about this silicone wire, which I swear by, and I found a really good supplier now that has it in stock, which is amazing. And it's 26 gauge I like to use, 24 or 26 gauge. I get some people asking, is that you can get 3, 4, 5 wires together, whatever, and just strip them as simple as that. And that is them stripped off, ready to be tinned and go in there, because it's just so easy to work with. There's our IC board fitted inside the pedal, and we've got this snake's wedding going on again, so now we're going to have to sort that out. I'm going to start off from left to right, and our first wire, if you like, is labelled up as number 2, and we can see that goes all the way across to the board up to R5 and C3. The left hand side of that is pin 2. All of our IC wires are now in place. Fantastic. I'm going to go ahead and just run from left to right on the bottom row, and then we'll do the same on the top row and wire everything in as we go along. So first up, we have the bottom left hand tag, and that is our input. So that wire is going to come from this tag here, round this wiring loom, round the back, and up to this back pin here, and then carry on through to the front left pin. And all that's going to do is our earth connection, when we're engaged, is going to go to our LED, and we're also going to have our input connected. But when it's disengaged, it's going to connect to our input and ground out this whole circuit so we don't get any noise. Again, as ever, I learned this off Marcus Reeves recently. Just goes to show that you can always teach an old sea dog new tricks, because I had no clue that I could do this and stop any background noise when the pedal's off. It just never occurred to me, and as soon as I seen him make the video, I was like, oh, of course. It just made perfect sense. Anyway, so let's solder that in place, and then we'll... Next, I'm just going to run the wire from there right the way round and through that switch. There's our input wired in. And if we follow along, we can see that there's one space here right in the middle with no wires on. And if we look at our drawing, the bottom of R4 comes out and connects to our gain pot. So I'm going to run a wire from here, round this wiring loom, right the way round the back here, and up to this pin or this lug on our gain pot. Last but not least, for the bottom row is this end tag here, which is our output. It's going to come out from the bottom of our clip and diodes here. We'll follow our wiring loom round, and we're going to get to pin 3 of our volume pot. We'll attach there, and then come out of the volume pot at pin 2, follow the wiring loom right the way round, and go to the output pin of our 3-pole double throw switch. Interesting stuff. I got to say, this is becoming a bit of a snake's wedding inside here, and it's getting a bit painful to wire in, because it stresses me out when the wires are everywhere. I know you can't probably see it properly because I've chose black wire on a black enclosure, but yeah, it's stressing me out a bit. I need to get through this quickly so then I can get some cable ties in there. That's the final connection on our bottom row sorted out, up to our volume pot, and then from our volume pot round and to the output pin of our 3-pole double throw switch. Now let's focus on the upper row. We can see that we've got our earth wires already in, now on our drawing. The only thing that's missing is our 9-volt DC, and that's coming from the second pin along, so the other end of our power diode. And that's what we're going to do, is we're going to run that from there round the back of everything and through to one of the resistors on our power filter board. The other resistor is going to come round, up, and then attach to our barrel jack to where either basically we can attach it to any side, anywhere along these two edges here. So as long as it's above these two resistors and attached to here, it doesn't really matter. I'm probably going to go ahead and attach it right there. Almost there now. That is our power wired up. We're ready to go. The last thing to add is our input and output wires. So remembering that the pedal's upside down, our input is on the left. So we're going to have a wire coming from here, round the wiring loom and up to the input of our 3-pole double throw switch. We'll then add in a little link wire, which is going to be our bypass wire between these two pins here. And then coming out of this pin, I'm going to go right the way round and up and to our output jack. And that is the last of our wiring. Get in, it means I can add some cable ties after that. I cannot wait. Right, there's all of the wiring complete. Thank the Lord. It is a mess and there's wires hanging everywhere, which is annoying me. But before we get to the cable ties, we're going to fit this. If we look at our drawing, it tells us that we need an LM741. And here we have that very thing, an LM741. This is actually the CN variant. I've used them in the past. I've got a big batch of these. They seem pretty okay. What I like to do is squeeze the legs together a little bit because they come flayed out, which doesn't really fit in. Make sure that you've got the little cutout on the top pointing to the top of the pedal, because if you get that the wrong way round, it just won't work. And then line one half of the IC up so the legs go in, and if you squeezed it and you know, got rid of that chamfer, the legs should now be sitting into the socket. You want to make sure Vis ID, we say in the Navy, which stands for visual identification. So Vis ID, that both halves of the legs are actually in the socket, because if you get one that's not in the socket, when you push down, it'll just bend the leg out and the IC is basically useless. You push down, you can hear it clicking, and there we have it. There's our IC in place. Now we're ready for the sound sample, but before we get to that, we are going to put some cable ties in. But before I put the cable ties in, I just want to check that the eyes light up when I plug this in. There you go. There's just something fun about that, isn't there? Anyway, I'm sure Randy would approve. And if not, Ozzy Osbourne definitely will. So, now I'm going to go ahead and get some cable ties in there, and then we'll do a sound sample and a test. Really, you should test it first so then you can work on the pedal without the cable ties in. But I just cannot. My anxiety just cannot handle having all these cables floating around when I'm testing it. I just can't. Now we've got some pretty pink cable ties in there. I'm ready to go. I'm going to get some knobs on it. We've got some nice big thick brass knobs to go on there, so it matches the decal. I'll get some knobs on it and then we'll get to the sound sample. Well, now it's that time again. It's time, of course, for the sound sample. I would love to know what you guys think of the sound of this pedal in the comments. I'm hoping it's going to transport me back into 1981. In fact, it was 4 years before I was born, but I'm hoping it's going to transport me back into 1981 with a stack of Marshalls behind me, a cream Les Paul, and a really massive hairdo. Or maybe I'm just hoping that I get that sound that Randy had. I'd love to know what you think. And remember, of course I'm not going to play any Randy Rhoads because I can't play guitar like Randy Rhoads. So for the people who are about to say, why are you playing a ZZ Top Lick or why are you playing something else? It's because that's all I can play. You are, of course, more than welcome to purchase one of these pedals and play anything you like on it, record it, send it to me, and I'll share it on all my social media. Thank you for supporting the show, and thank you for watching the video this far.